What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to find out limits for piecewise function. First example we have is finding the limit if it exists when function is 7 minus 4x when x is less than 1 and x squared plus 2 when x is greater than 1. In this case I'm gonna say limit of f of x when x is approaching 1 from positive side, which means that's greater than 1, we need to use this one. It's going to be limit of x squared plus 2 when x is approaching 1. That's going to be 1 plus 2, which is going to be equal to 3. On the other hand, we have limit of f of x when x is approaching 1 from the negative side, from the left hand side, so it means it's less than 1, so it's going to be limit of 7 minus 4x when x is approaching 1 minus. That's going to be 7 minus 4. So since the right limit and left limit are the same, it means that the limit of the function is when x is approaching 1 is 3. Next one, it says if the function f for x equal or less than negative 4 is equal to 6x, for x greater than negative 4 is going to be 1 minus 9x. If you want to find out if it's continuous and we have the limit, you need to go negative 4 plus. It means that from right hand side of negative 4 we need to use this one, which is going to be limit of, that's going to be 1 minus 9 times 4, which is going to be negative 35. And here limit of f of x when x is approaching negative 4 from the negative side, that's going to be 6x. That's going to be 6 times 4 is going to be 24. Since 24 is not equal to negative 35, it means that limit doesn't exist. Next example, limit of f of x when x is approaching 2. For x values equal or greater than 2 is x squared. For x values less than 2 is 2x. So we're going to say limit of f of x when x is approaching 2 plus, it's going to be x squared. Limit of x squared when x is approaching 2 plus, it's going to be 4. And the limit is f of x when x is approaching 2 minus is going to be limit of 2x. We need to use the other one. So it's when x is approaching 2 minus, that's going to be 2 times 2, which is 4. Since they're equal, we say limit of f of x when x is approaching plus 2 equals to limit of f of x when x is approaching 2 minus, that's going to be equal to 4. Therefore limit of f of x when x is approaching 2 is 4. This is the most proper way to state that. Since the right limit and left limit exist and they are equal to each other, we're going to say that the function is continuous and the limit of this function is 4. Next one, limit of f of x when x is approaching negative 1 and function is x squared plus 1 for the values less than negative 1 and 3x plus 1 for values equal or greater than negative 1. So I'm going to say limit of f of x when x is approaching negative 1 plus, that's going to be limit of 3x plus 1. It's going to be 3 times negative 1 plus 1 is going to be negative 2. And the other one is going to be limit of f of x when x is approaching negative 1 minus, it's going to be limit of x squared plus 1, which is going to be negative 1 squared plus 1, that's going to be positive 2. And we're gonna say that since right limit and left limit are different, limit does not exist. Next one. We need to find our limit of f of x when x is approaching -1 and f of x is 2x plus 1 for x values less than -1 is equal to 3 for x values between -1 and +1 and 2x plus 1 for x values greater than 1. So in this case, sometimes they can give you find out the limit of f of x when x is approaching 1 or x is approaching -1 or both of them. In this case it says x is approaching -1, so we just deal with these two. So I'm going to say limit of f of x when x is approaching -1 plus, it means that we need to deal with this one because x is greater than -1. That's going to be equal to 3. Limit of f of x when x is approaching -1 from the negative side is going to be limit of 2x plus 1 when x is approaching -1 minus. It's going to be 2 times 1 plus 1 is going to be 3. So since limit of f of x when x is approaching -1 plus equals to limit of f of x when x is approaching -1 minus equal to 3, I'm going to say that limit of f of x when x is approaching -1 is 3. The next example is the similar example to the previous one. The only difference is x is approaching 1. So we need to deal with these two. I'm going to say limit of f of x when x is approaching 1 minus. It means that for those values close to 1 but to the left hand side, we need to use this guy, which is going to be 3. Limit of f of x when x is approaching 1 plus is going to be limit of 2x plus 1. That's going to be 2 times 1 equal to plus 1 equals to 3. So limit of f of x when x is approaching 1 plus equal to the limit from the left hand side, left limit are equal. Therefore the limit of this function when x is approaching 1 is 3. Next example, limit of f of x where f of x is 3x minus 1 when x is less than -1, x squared plus 5x when x is between -1 and +1, 3x cubed when x is greater than 1. So since it didn't specify, we need to consider both. Limit of f of x when x is approaching -1 minus is going to be limit of 3x minus 1. That's going to be 3 times 1 minus 1 is going to be 2. Limit of f of x when x is approaching -1 plus limit of x squared plus 5x when x is approaching -1 plus. That's going to be 1 plus 5 equals to 6. Actually, that's going to be 1 minus 5 is going to be -5 in here is going to be -4. Then I need to find out limit of f of x from the left hand side when it's approaching to 1. That's going to be the middle one still, because that's for x values less than +1. It's going to be 1 plus 5 equals to 6. And finally f of x when x is approaching 1 plus is going to be limit of 3x cubed. It's going to be 3. So none of them are equal. This one doesn't equal this one, and these two are not equal. You're going to say that limit of f of x when x is approaching -1 and limit of f of x when x is approaching +1 do not exist. In this example, it says limit of f of x when x is approaching 2 or +2, where f of x for x values less than 2 is x squared, for x equals to 2 is 3, and for x values greater than 2 is 3x minus 2. In order to have the limit, we need to find out the right limit and the left limit. So it's going to be those x values close to 2 but slightly greater than 2, which we need to use the third one. That's going to be 2 times 3, 6 minus 2 is going to be 4. Then you have limit of f of x when x is approaching 2 minus. It's going to be limit of x squared when x is approaching 2 minus. It's going to be 2 squared. That's going to be 4. And since these two are equal, we're going to say the limit exists and equal to 4. However, at x equals to 2, the value of the function is 3, which is not important for us because that's the value of this function. However, we are finding out the limit. It means that slightly greater than that point or slightly less than that. The point at here is not important. Next one is limit of f of x, where function is x squared when it's less than 2, 3x minus 2 when it's greater than 2, equal or greater than 2. So we're going to say that x is approaching +2. F of x is 2 plus, we're going to use this one, limit of 3x minus 2 when x is approaching 2 plus, 3 times 2 minus 2 is going to be 4. Next one is limit of f of x when x is approaching 2 minus, so that's going to be x squared when x is approaching -2 is going to be 2 squared, and that's 4 as well, since right limit and left limit exist and equal the limit of the function at point x equals to 2 is 4. Next example, limit of f of x when x is approaching 2. For x values greater than 2 is 3x minus 3. When x value is equal or less than 2 is x squared. So that's going to be limit of f of x when x is approaching 2 plus. It's going to be 3x minus 3. Limit of 3x minus 3 when x is approaching 2 is going to be 3 times 2 minus 3 is going to be 3. Limit of f of x when x is approaching 2 minus is limit of x squared when x is approaching 2 minus is going to be 2 squared, which is going to be 4. And they are not equal. Limit doesn't exist. Next one, limit of f of x when x is approaching 2, where f of x is x squared for x values less than 2, x equals to 3, when x is equal to 2 is 3, and for x values greater than 2 is 3x minus 3. So it's going to be limit of f of x when x is approaching 2 plus is limit of 3x minus 3 when x is approaching 2 plus. It's going to be 3 times 2 minus 3, that's going to be 3. And limit of f of x when x is approaching 2 minus, it's going to be limit of x squared when x is approaching 2 minus. It's going to be 2 squared, which is going to be 4. So limit does not exist. Next one is limit of f of x when x is approaching 2, where For x values equal or less than 2 is 1 over 2x plus 1. For x values greater than 2 is 3 minus x. So limit of f of x when x is approaching 2 plus is limit of 3 minus x, x plus 2. So it's going to be 3 minus 2 equals to 1. Limit of f of x when x is approaching 2 minus is limit of 1 over 2x plus 1. When x is approaching 2 minus, it's going to be 1 over 2 times 2 minus 1 plus 1 is going to be 1 plus 1 is going to be 2. So I'm going to say that limit doesn't exist. Next one, limit of f of x when x is approaching 2, where you have negative 2x for x values equal or less than 2, and x squared minus 4x plus 1 when x is greater than 2. I'm going to say limit of f of x when x is greater than 2, approaching 2 from the right side, it's going to be limit of x squared minus 4x plus 1. That's going to be 4 minus 8 plus 1 is going to be negative 3. And limit of f of x when 2 minus is going to be limit of negative 2x when x is approaching 2 minus is going to be negative 4. So limit does not exist. Next one, limit of f of x when x is approaching 4, where x squared minus 3x when x is greater than 4, and 2x minus 5 when x is equal or less than 4. So limit of f of x when x is approaching 4 from the right hand side equals to limit of x squared minus 3x when x is approaching 4 plus, it's going to be 16 minus 12 equals to 4. And here on the left hand side we have limit of f of x when x is approaching, from the left hand side is going to be limit of 2x minus 5, which is going to be 8 minus 5 is 3. So limit does not exist. Next one, f of x is absolute function of x minus 2 when x is less than 2, and x minus 2 when x is greater than 2. So it's going to be limit of f of x when x is 2 plus is going to be limit of x minus 2. It's going to be 0. And the other one is limit of f of x when x is slightly less than 2. So when it is slightly less than 2, it's going to be negative. So the answer is going to be limit of negative times x minus 2 when x is approaching 2 minus. So that's going to make it as 0 as well. So limit exists. Next one, you need to find out the limit in 2 points. One of them is at 0, one of them at 2. So limit of f of x when x is approaching 0 from the negative side is going to be limit of x cubed plus 1. 0 plus 1 is going to be plus 1. Limit of f of x is approaching 0 from the right hand side is going to be it's going to be 0 plus 1, that's going to be 1. So limit exists at x equals to 0. The other one is limit of f of x when x is approaching 2 plus is going to be limit of negative x squared plus 10x minus 15 when x is approaching 2 is going to be negative 4 plus 20 minus 15, which is going to be positive 1. And the other one is limit of f of x when x is approaching 2 from the left hand side is going to be limit of negative x plus 1. That's going to be negative 2 plus 1, which is going to be negative 1. So limit of f of x when x is approaching 0 equals to 1, and limit of f of x when x is approaching 2 does not exist. Find the value of c that makes the function continuous. It means that at 2, limit of when the right limit and left limit are equal, it means that the function is continuous. It means that 2 squared plus c equals to 4 times 2 plus 4 times c plus 1. So that's going to be 4 plus c equals to 4c plus 1. That means 3c equals to 3. So c will be 1. Next one has to be continuous. So limit of f of x when x is approaching 4 plus from the positive side. Limit of f of x when x is approaching from the negative side. When they are equal, we're going to say limit of 2x plus 3 plus c when x is approaching 4. Limit of 5c minus 4 when x is approaching 4 plus. It's going to be 8 plus c equals to 5c minus 4. It's going to be 12 for c. So c will be 3. Find the value of c if the function is continuous. So again, the limit of f of x when x is approaching 2 plus equals to limit of f of x when x is approaching 2 minus equal. It means that 4 minus 1 over 2 times 2 equals to square root of 2 plus c. So 4 minus 1 is going to be 3. So it means that 2 plus c has to be equal to 9. So c will be 7. Next one, determine if function f of x is continuous. So limit of f of x when x is approaching negative 4 minus is going to be equal to limit of x when x is approaching negative 4 is going to be negative 4. Limit of f of x when x is approaching negative 4 plus is going to be 5. So that doesn't exist. Limit of f of x when x is approaching 3 from the positive side is going to be 3 squared minus 5. That's going to be 9 minus 5, which is going to be 4. And here, when you find out the limit of f of x when x is approaching 3 minus is going to be 5 as well. So these two are not equal. These two are not equal, so limit doesn't exist and not continuous. Next one, determine if a function is continuous. So limit of f of x when x is approaching negative 1 from the negative side equals to limit of f of x when x is approaching negative 1 from the positive side is going to be 3 times negative 1 plus 1 equals to 2. That's going to be negative 2. And here 2 minus negative 1 squared is going to be 2 minus 1, which is going to be plus 1. So limit does not exist and it is not continuous. Next one, limit of f of x when x is approaching negative 1, where f of x is x plus 2 for x values equal or less than negative 1, and a negative x plus 2 for x values greater than negative 1. So it's going to be limit of f of x when x is approaching negative 1 plus. That's going to be limit of negative x plus 2 is going to be 3, and limit of f of x when x is approaching from the negative side it's going to be limit of x plus 2. When x is approaching negative 1 it's going to be negative 1 plus 2 is going to be plus 1. So they are not equal. Limit doesn't exist. Next example, limit of f of x when x is approaching 2 for these two. So it's going to be limit of f of x when x is approaching 2 minus is limit of negative x plus 4. That's going to be negative 2 plus 4. That's going to be positive 2. And limit of f of x when x is approaching 2 plus is limit of negative 2x plus 6. Negative 4 plus 6 equals to 2. So limit of f of x when x is approaching 2 is 2. Next one, limit of f of x when x is approaching 1 over 2, where f of x is 4x when x is equal or greater than 1 over 2, and 1 over x when x is less than 1 over 2. So limit of f of x when x is approaching 1 or 2 plus, it's going to be limit of 4x. That's going to be 4 times 1 over 2, which is going to be 2. And limit of f of x when x is approaching 1 over 2 from the negative side is going to be limit of 1 over x. That's going to be 2 as well. So limit of f of x when x is approaching 1 over 2 is going to be 2. That exists because the right and left limits are equal to each other. Next one is limit of f of x when x is approaching negative 0.5. So we're going to say limit of f of x when x is approaching negative 0.5 is going to be limit of x squared minus 0.25 when x is approaching negative 0.5. It's going to be 0. And limit of f of x when x is approaching negative 0.5 from the negative side is going to be equal to 1. So limit does not exist. Next one, determine if f of x is continuous. So we're going to say that limit of f of x when x is approaching 1 from the negative side is x. Limit of x when x is approaching negative 1 is going to be 1. Limit of f of x for when x is approaching 1 plus is going to be limit of 1, which is going to be the same. So here that exists. Limit of f of x when x is approaching 2 minus is 1. Limit of f of x when x is approaching 2 plus is 3. So we're going to say that limit of f of x at when x is approaching 1 exists, and limit of f of x when x is approaching 2 does not exist. Find the value of c when f of x is continuous. So we're going to say limit of f of x when x is approaching 3. That has to be equal to 2 plus root c. So it means that the limit of f of x when x is going to the left hand side and to the right hand side, that has to be equal, and it has to be equal to the value of the function. So in that case, it's going to be 3 plus 3 is 6, 2 plus root c. Root c is 4. So it means that c is 16. Next one, find constants a and b such that the function is continuous. So in this example, we're going to have negative x when x is approaching negative 2 minus has to be equal to limit of ax squared plus b when x is approaching negative 2 plus. It means that negative times negative 2, which is 2, a times negative 2 squared plus, so it's going to be 4a plus b is going to be 1 equation. The other one is ax squared plus b has to be equal to c when x is 0. So it means that b is 6. And then when you sub it there, it's going to be 2 equals to 4a plus 6 is going to be 4a equals to negative 4. A will be negative 1. So a is negative 1, b is 6. And finally, the last example is determine constants a and b such that f of x is continuous for all values of x. So limit of f of x when x is going from the positive has to be equal to limit of f of x when x is going toward the negative side of the. So I'm going to say that 5a plus 3 has to be equal to 8, has to be equal to actually x squared, which is 25 plus 5b plus a. So in that case, you're going to say that a equals to 1 when you solve this one, and when you sub it here, you have 8 equals to 25 plus 5b plus 1. So that will be 8 minus 25 minus 1 equals to 5b. So that will be negative 18 equals to 5b, which is going to be b equals to negative 18 over 5. And this is going to be the final answer. I hope you enjoyed this video. Please leave me a comment if you have any question. And please don't forget to subscribe to this channel. You can have access to many other videos regarding calculus, math, and other topics in physics and chemistry. Thank you for watching and have a great day.